Okay, before I go over the delta epsilon proof for that limit in number 1, and again, this is for, those A students who really want to see the fancy stuff. Future mathematicians, people who like to get a lot of exercise, those kinds of people. All right. A function f of two variables approaches, remember I always underline the word that is being defined, approaches is the word being defined, or goes to, and that is now a property that a function f can have within this definition. So a function f of two variables approaches a number L as xy goes to x naught, y naught. Okay. If there is a function delta whose domain is the interval 0 to infinity and his codomain is the same. So this is a positively valued function. No matter what you put into delta, you gotta get out a positive value. Okay, so that is to say delta is going to be greater than 0. Okay, so if there is a function delta such that the difference between, get out of their hand, f of xy and L is less than epsilon for all pairs of numbers xy, such that x minus x naught squared plus y minus y naught squared, that is the distance between the point xy and the point x naught y naught, is less than delta epsilon. Okay, end of definition. So let's recap. This says, reading kind of backwards, that whenever xy is really close to x naught y naught, within this distance, delta, that forces the value of f to be within epsilon of L. So this limit we're talking about exists if there is some number L such that you can force f to be arbitrarily close to L by choosing x to be arbitrarily close to x naught, and similarly for y and y naught. All right, so let me just review some shorthand. L is called the limit. This symbol is shorthand for goes to, or the thing we're primarily defining up here. These are two things I'm simultaneously defining as synonymous. Shorthand for goes to or approaches. And then we say that, and it's all shorthand, for the limit as x, y goes to x naught, y naught. Yeah. And then, let's see, I should say there will be some object right here of, and then underline. Okay, so we read this way. The limit as x, y goes to x naught, y naught of, and then whatever's there. Yeah, maybe that's an f of x, y, all right? So the limit is referring to L. And of course, the arrow that takes place, that appears right there, is shorthand for goes to, or approaches. Sorry if that looks like an F. That's supposed to be more R-like. R-like. Partially fixed. All right, now the task of actually doing the delta epsilon proof for okay, we had 3x squared minus y squared plus 5 over x squared plus y squared plus 2. And we want to say that that is close to 5 halves under some conditions on the distance between x, y, and 0, 0. So we want to say that this is going to be less than epsilon at some point. So let's make a chain of less than or equal to's, okay? So at some point at the end of this chain of less than equal to's, I'm going to put an epsilon, and that's going to guarantee me that epsilon is bigger than that thing, or this thing is less than epsilon. First thing I'm going to do, and this is usually the case, is combine these two terms so I get something that just more obviously looks like it gets really small. Right, in the end I want to say that this whole expression between the two walls there is going to 0. So what I'll do is I'll get a common denominator. Okay. 2 and the denominator there, and this denominator is complicated. So let me do the 2 times the numerator here first. That's a 6x squared minus 2y squared plus 10. And then I'm going to have minus 5 times that denominator, so 5x squared. And I need more room. Minus 5y squared minus 10. Okay. And then downstairs, the product of the denominators is 2x squared plus 2y squared plus 2 times 2 is 4. Okay. Now, of course, these two things are equal. So less than or equal to includes the case equal to. I am not a liar. Okay, I'm going to continue replacing my expression with things that are either bigger or equal to. Because, again, in the end, I want to put epsilon right there and say that this thing is less than epsilon. So I suppose next thing I'll do is I'll simply simplify. Okay, 6x squared minus 5x squared, there's only one x squared left. And how many y squareds are there? Looks like there's negative 7 y squareds. Don't like that. Plus 10 minus 10, perfect. But the reason that's perfect in my mind is because notice that now, in the limit that xy goes to 0, 0, the numerator will go to 0. The denominator won't, which is fine with me. The numerator goes to 0 and the denominator doesn't. I'm okay. Okay, now once again, I want this to be less than epsilon. But what I really want is to, I want to think about what this function delta has to be, right? I want to make that condition look like that inequality. So before I write less than epsilon, I would like to have an expression that only involves x minus x naught squared plus y minus y naught squared. So let me work in that direction. Say downstairs, I could have an expression that only involves x squared and y squared. I could factor out the 2 and have 2 times x squared plus y squared. That would be very nice. However, I'm going to be more ambitious than that. What I will do is, you know what? If I'm going to make a bigger expression, then making the denominator smaller will do it, right? So if I make the denominator here smaller, I'll make the overall thing bigger. I'm just going to delete those two definitely positive terms, 2x squared and 2y squared. And then, let's see, upstairs, I need to definitely make upstairs bigger. Let's see, what could I do? I could add, what would definitely make upstairs bigger? Gosh. Oh, you know what I could do? I could add 8 y squareds. That would leave me with simply a y squared, right? So that right here, I added 8 y squareds to the numerator rather. If you add 8 y squareds upstairs, you're definitely making upstairs bigger. See, the reason I did that, and it's certainly true, right, that this is bigger than that, and this thing is going to go to 0. This thing is certainly less than epsilon for all ordered pairs of numbers xy, such that x minus 0 squared plus y minus 0 squared. Why did I write that? Because we are looking at the limit as xy goes to 0, 0. less than, now just rearranging that, I'll have 4 times epsilon. Just multiplying both sides by 4. Okay, now 4 of epsilon is what I'm going to define to be my function delta of epsilon. Okay, that is to say, there exists some function delta such that whenever the distance between x, y, and 0, 0 squared is less than delta of epsilon, I'm guaranteed that the difference, or distance if you like, between my algebraic expression evaluated at x, y, and 5/2 is less than epsilon. Okay, so I can conclude the limit as xy goes to 0, 0 of that big old clunky expression 3x squared minus y squared plus 5 over x squared plus y squared plus 2 is equal to 5/2. But of course I had to have the suspicion that the limit was 5/2 before I even started this procedure. Okay.